Okay, we're back. Oh, why is the counter still not correct? Oh, damn it. I wish I could reinitialize the counter. So that's exactly why I started the stream a bit earlier than 3. It's to fix this kind of issues, but it seems that I cannot reset the timer. It's stuck at 8 minutes, and I would really prefer it to be well, exactly at 1 hour. And yeah, it doesn't work. It's not a big deal, but it's a bit frustrating. So anyway, let me check if there's anyone on the stream already. Yes, 2 persons. Hi, glad to see you. We're gonna start at 3 sharp. I'm just there to try and fix the well, the setup, and as you see, there is a 7 minutes countdown, and it's super frustrating because basically we are here for an hour, not 7 minutes. I hope you can hear me well. Can you confirm in the chat? Is the sound okay? I've put a bit of music in the background, so can you hear it well, or you know, as you prefer? Is it too loud or not? I'm gonna check the camera as well. I'm just going to make it a bit. No. Maybe like that. Not really perfect. Oh shit. Okay, last attempt. Okay, good. Good. Okay, ready to start. Just this annoying counter that is stuck at 5. If anyone is a specialist of, you know, Twitch and OBS and this kind of things, I would be super glad to know how to reset this thing. you can right-click the browser source that holds the countdown widget. Properties, refresh cache. Okay, let's try that. Oh, that's complicated. And we start in 1 minute. Right-click the browser source that holds the countdown widget. Properties, refresh cache. Oh, okay, maybe I can do that as well. No, no chance. Refresh browser when send becomes active, then trigger the browser when you go in there. Oh, that's complicated. Let's try it again. And refresh. Save. No, the counter stays stuck. I'm really stubborn, but I'm gonna have to stop now. Yeah. Never mind. Never mind. Okay. Welcome everyone. I hope you are in a nice place. We're gonna be busy today with an important topic, which is the visualization and exploration of attributes in Gephi. This doesn't sound like like a very advanced or sophisticated topic, but actually preparing for today, I have realized that it is really fundamental, and hopefully I really think that you're gonna learn a lot. So this is not a lecture, this is Twitch, so you can participate in the comments. I would be glad to have you interact, make suggestions, or asking for clarifications. Otherwise, it's going to be me talking for an hour. I repeat, if you see that in replay or if you didn't hear me well, but the counter that says 7 minutes is wrong. I couldn't reset it to an hour, but we're going to spend an hour on the topic, and I realized that I should update. If you leave me right a second, I should update the topic for today that you see at the bottom left corner. So today is visualizing and exploring attributes in Gephi. Right, and if I save it, yes, you see the result right there. So let me take a bit of water and coffee here. Good. Another important thing is that you can find the resources for this session at the link here. This link will be posted as the first comment on the YouTube replay. So we should get started, because let me show you that I have a very long list of items to cover with you, from basic information to the most advanced topics. So this session is for beginners, full beginners, and advanced users of Gephi as well. So, visualizing and exploring attributes in Gephi. Just a short note on what are attributes. So you might know that Gephi is quite special in terms of software for the exploration of networks. You have a lot of classic softwares that visualize networks only as dots connected to other dots, and that's it. The software conceive a network only in terms of their topology. That's the technical term. So this software specializes in exploring networks only in terms of the connectivity patterns, and it's fine. Gephi and a couple of other software make room for networks that are a bit richer in terms of the information they carry. In Gephi you have networks with nodes that connect to other nodes, of course, but each node, and this is where attributes come in, each node and each connection or edge can have attributes. So information that is specific to a given node, or a piece of information that is specific to a given edge. Sometimes people call these attributes metadata, like the metadata of the network. So that's it. An attribute is some supplemental information on the node. Thank you, Totemat, and I forgot that indeed. I just had put it a bit. I had put the music a bit loud for the introduction, and I forgot to tune it back to a background level. I hope it's better now. Please let me know if I should. Thanks a lot. Thanks a lot. Otherwise, the whole stuff is. Yes, so attributes are this information on the nodes and the edges that help you understand better, what they are about. I follow my script. It's super important to realize that nodes can have attributes, but edges as well. So a connection between two nodes can have can carry a lot of information. For example, if two people are friends, so person A, person B, a connection between them means that there is a friendship between the two. An attribute of the edge of the connection can be the intensity of this friendship. Is it a close friend, or is it just somebody we know not too well, or maybe the date when the two friends met, these kind of things. In Gephi, you will see that, and in other software, I think that Neo4j has that as well. Neo4j is a database to host or to store graphs and networks. You will see that one way to call an attribute on a node or an edge is called a type. Okay, so what kind of attributes can you create? Basically, you can create many types of attributes, but there is one you have a couple of categories I would like to highlight. The first one is textual attributes. So you can have anything written in text that will describe your nodes or your edges. The second kind would be numbers, like quantities or numbers in general. And the last one I would like to emphasize is true, false values. So maybe to make this a bit more visible, I'm going to open Gephi and we're going to have a look by ourselves. So what I'm going to use here is a version of Les Misérables network. Les Misérables is a very famous, so why can't you see Gephi? Yes, because it's there. Les Misérables is a very famous type of network, and one of the reasons is that why it's famous is that Gephi makes it available. When you start Gephi, you have a welcome menu that offers you to open the Les Misérables network. I have added in the resources, and let me post the link here. In the resources for this session, I have posted an extended version of Les Misérables network that I created. Basically, I just added one attribute to the nodes, the gender. So Les Misérables is a famous novel by Victor Hugo. The network consists in the characters of the novel, and they are connected if two characters are connected if they appear close to another in the novel. And I have just created a version of Les Misérables, which, let me find where did I put it? I've created a version of the network where you see the gender of the characters, and I'm opening it now. Okay, so you should see it. Yes, the zoom is here. So 74 characters. It's okay. The network to start with is completely disorganized. And if you shift to the data laboratory, so as you see, I just clicked on data laboratory here. You see the list of the characters in the network. Oh, and the timer has reset. Great, I don't know how or why. Brilliant. So the information I have added compared to the original network for Les Misérables is this one. I have added a gender column, M for male, F for female, and this is what an attribute is, right? For each, so can I select? Yes. I select a node at random. Isabeau is the label of the node. Oops. Right there. And so let me start from the beginning. You have an ID, so that's the left column, an ID, which is here a number, the ID of the node. Then we have the label of the node, and usually the label is the key information for the node. So typically here that would be the name of the character. And what I have added is this column to the right, which is called gender, and which shows the gender of the character. So M for male and and F for female. So that's simply what a character, an attribute is. If we move to the ages, so let me zoom in. We are in the nodes table right now in the data laboratory. If we move to the ages, we see that an age is made of several information. The source node, the target node of the age, the type of the age is directed or undirected, the ID, so a unique value for a given age. We can have a label for each age. In this case, it's empty. An interval if we have something that evolves in time, but we don't cover that today. And last, a very classic attribute for Gephi, not every software supports this, but Gephi does, the weight of the age, a kind of measure for its intensity. And it's a decimal value. You can have a number with decimals there. I insist that you can add other attributes. It's not limited, and Gephi allows you to add attributes and visualize them. Okay, so all of that are preliminary remarks. Now we are finished with these preliminary remarks. We can move on to some things that are going to be a bit more practical. The first thing is on my list is how to make attributes visible in Gephi, because right here we have them as well, columns in tables, but Gephi is powerful because you can basically have a visual sense of your network. So how do you show attributes right there? Before we start, as usual, what I will do is apply a layout. So I choose Force Atlas 2, which is the most interpretable one, in my opinion. I click on Run. To apply this layout, as I stop it, I'm going to expand it by augmenting the scaling parameter. It is 10 by default. I'm going to make it 50. Can I do that here? Yeah. No. Sometimes it bugs. I don't know why. Why 50 is not accepted? Why can't I change the value here? That's so annoying. Okay, leave it like that. It's going to come back at some point, I suppose. Okay, so we have these connections between the characters in the Les Miserables novel. How do we show the names of the characters? So to come back to the data laboratory, the names are, nodes. The names are what you see in the label, right? Let me zoom in. The names are in the label column. How do you show that? There. It's very simple. What you do is click on the T. That's for the age. How do you show that? Right. You click on the T there, and the labels of your nodes are going to appear. Of course, it's completely ugly, so you can use this slider on the right to reduce the size of your labels, which makes them easier to read. Another way to do exactly what I have done is to click on this upward arrow, which is almost hidden at the bottom right, and it opens a panel that is maybe a bit more explicit than the icons. So in this panel, you click on the Labels tab, and at least to me, it makes more sense than the icons that I always forget about above. So yes, that's how you show labels on screen and how you resize them. Let me resize them here. So you see, the next thing you can realize that these labels overlap. So a way to fix that is, well, let me show you how you fix that manually. You select the icon with the little hand there, and that allows you to move icons one per one. By the way, you can move groups of nodes. You know, I just moved nodes individually there. You can move groups of nodes by clicking on configure. You increase the diameter. Oops, that's super big. That's quite big still. Yeah, you can increase the diameter of the selection region. And now when I'm going to move, you know, all the nodes covered by the selection area are going to be displaced. So that's kind of a nice trick. But to make labels stopping from overlapping, what I just showed you is not super useful. I would get back to a small selection area and move stuff. Of course, this is super slow and boring. So actually, the developers of Gephi created two ways to automatize the you know, the spread of the nodes so that their labels don't overlap. The first one is called label adjust. And maybe you didn't see it because it was super quick, but clicking on label adjust in the layout panel moved the nodes slightly so that their labels stop overlapping. Another layout does exactly the same. It's called noverlap, so for no overlapping. And when you click on it, same, right? Well, just move the nodes around so that you can read the labels better. It's still far from perfect, but we're gonna continue and improve on what you see on screen. Okay, so this is how you would show the labels of the nodes. How would you show a label from an age? A classic, as I said, a classic attribute of an age is their weight. Let's go back to the data lab, and then I switch to the ages tab, and let me zoom in there. The weight of an age defines its intensity or strength. And by the way, I would recommend using values ranging from 1 to 10. If you use values that would be much bigger than 10, you would have strange effects like two nodes being connected by an edge which is super strong with a weight of 50. These two nodes would never spread out. If you use a force atlas layout, you know, to spread nodes according to their patterns of connectivity, two nodes that have a very strong, like 50 type of weight would never, they would never appear apart from each other. So it's better to rescale your weights from a 1 to 10 scope. So anyway, how do you show on the screen that you have big ages and or big weights and small weights? It's simply with the thickness of the age. So let me zoom in, and actually that already happens here. Eponine and Marius appear many times in the same parts of the book, so the weight of the age is has a large value, and that translates visually with a thick age compared thicker than, you know, other ages like this one, which is less thick. Why is it so big there? Okay, good. And one way to recalibrate the thickness of the edges is to use this slider, I guess. Yes. So this slider, let me untick this stuff. This slider that you can see here helps you make your edges thicker or thinner, but always preserving you know, the proportions of the weights. But that can be useful if your view is cluttered, to actually play with this slider to make the edges less thick. Okay, so maybe all of that is pretty common to all of you, but maybe not, and maybe that some beginners find that useful. So we covered the basics here. Now we can move to other ways to represent attributes. So what would you suggest? I mean, you're always free to add some questions or comments in the chat. What I'm going to do here is show you how you can use colors to represent attributes. So let me think. The thought I just had was, how can we color the nodes that are male in green and the nodes that are female in blue? Well, so I don't write, oh well, partition, yes, of course, partition. So let's, sorry, well, that's the point of Twitch, right? You are supposed to be not improvising, but you are supposed to be basically not over preparing, and I think that's exactly what happened there. So what if you wanted to, let's go back to the data laboratory, let's go back to the tables of nodes. What if you wanted to basically represent these genders on the visualization with colors? So again, painting all the male characters in green and all the female characters in blue. Why would you like to do that? Well, oops. There is a workspace that I should close. Okay, I've done it. Why would you paint these attributes, you know, the gender of the characters in color? Well, to allow you to immediately see on the network, for example, whether male characters are central in the network or whether they are peripheral, to see whether you have you know, male characters that tend to connect with male characters, or is it diverse in terms of gender connectivity. Here, you know, with what we see on the in the visualization, it's not immediately obvious to see, like, are female characters central? Not super clear. So one way again to do it is to paint the nodes according to their attributes, to their gender attribute. To do that, we can go to partition, which is right there. We choose gender as an attribute, and this means that, and as you see, it's pretty obvious, it's gonna color all the nodes that have M as an attribute, as a value for the gender attribute, in pinkish. And it's gonna color all the characters that have an F as a value for their gender attribute in green. So I said that I wanted different colors. I said blue for males. So how do you change that? You just click on there. Oops, you click, you long press, and you then choose the color you want. So kind of bluish stuff. I think that's what I say, right? Blue for males and green for female, or the reverse. But that's how you choose things. If you want, or if you need more, you know, scientifically and properly defined color palettes, you would be able to use some defined by Gephi, and I think, if I'm not mistaken, that this part is a contribution by Mathieu Jacomi and colleagues at the Sciences Po Media Lab a couple of years ago. So, well, you do just that, and then you apply. The result is this one. You, at a glance, you see where are the male characters and where are the female characters. You see that the names of... I showed that you could paint the nodes in colors that correspond to the values of their attributes. In this case, the male characters that have an M in their gender attribute are going to be painted blue, and the female characters, these are the characters that have an F for value in their gender attribute, are going to have been painted in green. And I've just done that by clicking on apply in this appearance partition subtab. Okay, all of that is pretty you know, standard, I would say, in Gephi. Let me highlight that the labels have not changed colors. They have remained completely black. So one way to have the colors, you know, have the labels of the color of the nodes is to stay in this panel there, and you click on labels in this tab there, and then color here, you in the drop down menu you click on object, and now you have the labels of the same color of the nodes. I suppose we could have the same effect by, let me zoom in here, by using this stuff here, label color. Let me, yeah, we could have done that right there, but you know, painting the labels specifically. But I suppose that a more classic workflow is to paint the nodes, and then you use this setting here to have the labels adopt the same color as the nodes they describe. While we are there, we can also mention that as a default, of course, you have the you know, the label. I mean, what the labels show is what you find in the label attribute. That makes absolute sense, right? But in principle, nothing would prevent you from having the gender displayed instead of the name of the node. And to do that, it's super simple. You just go back to overview, and you click on either here, configure, you know, labels, configure, or here, this little icon. It's the same. You can click on here, and it says, well, let me zoom in. Yeah. nothing prevents you from actually showing in the visualization something else than the label. You can show the gender. And if we do that, oops, why are the, we see them, but just when we overlap, when we hover on them. I'm not exactly sure why. That's interesting. Oh, it's just that they were super small. So I used the slider to make the labels bigger, so that we see that, yes, we can have any attribute displayed as a label, not just the label attribute. In this case, that's pretty funny and weird because, you know, the gender is already expressed by the color of the node, so we don't really need to have the gender visible a second time with the name of the gender. We can, I think it makes absolute sense to come back to the label as you know, the name of the character as a label. And please realize that, oops, that's here actually, we can have the two together. It's not just either or. You can have everything displayed. So let's try that. Yes, of course, it's super big. Let me slide down. And you see that we have the names of the characters, and then a dash, and then a second attribute, which is their gender. Okay, let us go back to have simply the names. So I unselect gender, and yeah, that's classic. How much do we have? 30 minutes. Okay, maybe I should go faster. We have plenty to cover. Yes, what else could I add on this topic? Yeah. Well, we're gonna continue, and so I see Alexandre Zonin. Hi, Alexandre or Alexandro. Glad to see you here. I hope, well, I'm just really glad to see you here. We interact online, and that's another channel where we meet. Okay, so let's move on. I would like now to show you a way to explore attributes when they relate to quantities. So here, as you see, male versus female, these are qualitative attributes or categorical attributes. You have different categories, male, female. But what if the attribute that you would like to investigate and explore is continuous and quantitative? So let's get one of such attributes. A classic attribute is the degree. It's convenient. A degree simply means the number of connections that a node has. So in this case, number of connections. So first we need to get this number as an attribute. One way to do that is to use the statistics panel in Gephi. It will compute the degree for all nodes for us. I can't remember, but maybe I think it's network. No, network diameter is going to be between centrality, simply average degree, I suppose. So you click on run. Yes, and it computes the degrees of the nodes. So how many connections each node has. That's it. You can now switch to the data laboratory, and when you look at the right, of the screen, you will see that a new column has been added called degree with numbers in it. It has been added because we have, run the statistics. So if you click on the title of the column, it orders the value. It can be super convenient. So as you can guess, the character that has the most connections, I would say, is Jean Valjean, who is the main character of the novel. So pretty consistent. Oops, why? Oh, interesting. It's, my shortcuts get all messed up. Okay, a degree of 36. It has 36 connections. Okay, now we have an attribute that is not categorical in nature, but which is continuous. So let's switch back to overview and let's visualize this attribute. How do you visualize quantitative attributes? The classic way is to simply rank, it's to use the size of the nodes as a visual clue for the, for the value of this attribute. So a small value for the degree, the nodes that have just a few connections, they're gonna be small. And the nodes that have plenty of connections, so they have a high value for the degree, they're gonna be big. It's pretty intuitive. To do that, you go in appearance and then you go to, well, maybe the first thing you would do is, click on this thing there, this icon. So this icon with, concentric circles refers to the size of the nodes. So you're going to rank the size of the nodes according to what? According to their degree. You have twice degree because actually, well, never mind, but Gephi already computes the degree without you to, ask for it as we did previously. But for the sake of being clear, I still computed the degree, but as a result, we see it twice in the drop-down menu. Okay, so the size of the nodes are going to be changed according to their degrees. So what should be the minimal size of a node and what should be its maximal size? Maximum, I would put 20, I think it's, oh yes, but this thing still doesn't compute. Oh, that's a pain. And if I do that, I should change my shortcuts. Never mind. We're gonna just do it manually to 15, and we click on apply, and we switch back to the view, and you see that our attribute is now visible in the sense that at a glance of an eye, we can see that the nodes that are very much connected are just the ones that appear as the biggest on the screen. Okay, so that's pretty common. Now what I'd like to introduce is the notion of spline, which is something that you can see there. Here. A spline is a way to tweak and shape the way the size of the nodes is going to increase with the value of the attribute. So if you don't use spline, there is a kind of expected relation between the size of the node and the value of the attribute, right? The attributes, the bigger the value of the attribute, the bigger the size of the node. And the two values, the value of the attribute and the size of the node, they just move in lock with each other, which is again pretty much what you would expect. But the spline feature allows you to play with that in the following way. So here what you see is, again, the default. This line represents by how much the size of the node will increase when the value of the attribute increases. And you see that it goes together. When the size of the attribute increases by 20%, the size of the node is going to increase by 20%. Super good, right? And so on and so forth. And if you multiply the value of the attribute by 100%, the size of the node will double. It will increase by 100%. What you are able to do is oops, I should, yeah. What you're able to do is move things around. So you have two, what I did is I selected this kind of bluish button, and you have a second one here that you can just drag around. Why would you do that? You do that if you want that when the size of your, when the value of your attribute increases, you don't want the size of the node to increase a lot, right? It's going to increase very slowly, and it's going to increase really just for the maximum values of your attribute. But for like most of the values of your attributes, the size of the node will remain super low. Or you might want the contrary, that, so you have to push all of that here. The contrary, that even if you are still at one of the lowest values of your attributes, poof, the size of your nodes shoots off and becomes super big quickly. So that's what it can do. What Gephi provides you is some predefined preset for your convenience. You can just select predefined curves or splines. Again, this one is the default one. So can you guess that if we pick this one means that the nodes are going to be close to their max, the nodes size are going to be close to their maximum value, even if the attributes values are low. So let's pick this one. I close and I click on apply, and as you see, all the nodes get super big, even the nodes of even the nodes that have very small degrees. Let's choose the opposite spline, the one that keeps the node sizes super small. So close here, and I apply again. And in this case, all the nodes sizes remain low, except for the biggest value, which is by Valjean. So just to finish on this, I just explained technically what the thing does, the spline. But why would you use it? You would use it because in some cases the values of the attributes that you want to visualize are not distributed uniformly across the spectrum of all possible values. So if you have values for an attribute that would go from 0 to 10, but all the values are actually concentrated between 9 and 10. You have a value which is 1, but all the others are between 8, 9, and 10. In this case, you might want to have the values between 8, 9, and 10 to be spread artificially, kind of, with the spline. The spline will make it that the values between 8, 9, and 10 will translate into node sizes that will vary much more than just between 80 to 100%. That makes it for it's just much easier to observe the differences between these values than if they were all compressed in or reflected in nodes that would have all almost the same size. A big warning there is that if you use this spline for your personal use, it's perfectly fine. You know what you're doing and you are fully in control. But if you ever use Gephi to explore a network and then share it to an audience, the audience can be completely fooled by the visual of the network that you're going to show them. If you use spline in some ways and you don't tell your audience. So you have an ethical duty, a deontological duty to share with your audience the parameters that you use to visualize your graph, and in particular, if you ever used splines, you should inform your audience about the parameters of the splines that you used. Before we move to the last and important topic, I would like to give a last hint to make the graph visible. So first, let me remove this very extreme spline, and let's go back to the default. Okay, so that's a graph we have, and I would just like to highlight the fact that if you have a textual attribute, just like the name of the characters there, you might want to make it more visible than they are here. And one way to have textual attributes more visible is to basically remove the nodes from the view so that only the text appears. To do that, I would suggest you to go to Appearance, click on here this icon for the size of the nodes, click on Unique then, and set it to 1. So you basically resize your nodes to a very small size. So let's do that. Okay, now your nodes are super small. I think that what you can do, if you want to have the same effect, possibly, no, I thought you could, but no, it has been removed or is different. No. Okay, so that's how you would completely remove the nodes from view so that your textual attributes are more visible. In this case, I think it's still a bit, what you could do is also, it's a bit daring, but you can also remove the edges from view. There is an icon there, right? And then I would do a bit of an overlap again. Oops, overlap doesn't really work there. Yeah. And this way you have a really unencumbered view of the textual attributes. I agree that without the links it's a bit less visible, but you can basically, Gephi is super powerful. You can just switch back and forth between the viewing of the links or just removing them. Another thing that can be useful is using this light bulb there to switch to a dark background, and that can be also useful to have the eye explore better the network. Okay, Now, and to conclude, we're going to go to something which is pretty advanced and pretty nice, I suppose. It's the way to visualize attributes which are the result of your exploration of the network within Gephi. So let me demonstrate that. Let's say that you would be interested, so it's an example I have prepared. Imagine you would like to show only the labels of the characters that have connections with a different gender. So let's imagine that you would be interested in showing the labels of the characters that interact with the opposite gender. So that's a pretty specific query, but that would be something that basically would be hard to, not hard, but it would be like complex and a bit boring to do outside of Gephi. In Gephi, you can do that pretty easily. So again, just to repeat, we would like to identify through their labels, just by showing the labels, the characters that are connected with characters of the opposite gender. How would you do that? So to do that, you would move to the filters panel in order to identify the nodes that connect with the opposite gender. So the filter panel is always a bit intimidating because it has some, non-intuitive lists of filters. So it's normal, you have to practice and tinker a bit. I myself, I found the filters I needed after basically iterating and making some mistakes, but the end result would be this one. So I would select the logic is that you nest the filters and you start with the last one that you want to be applied. So I drag the degree range filter, meaning that I want to see on the graph only the, maybe if I, yeah, you're gonna see it here. I want to see only the nodes that have at least one connection. Then I expand it and I see that I can drag a subfilter there. So let's go and find a subfilter. I want to see the nodes that are not, so there is a not. I want to see the nodes that are not connected with the same gender. Oops. And which gender? I don't want to see the males that are connected with males. I don't want to see these ages at least. And second, I don't want to see the female characters that are connected with female characters. I don't want to see the ages either. So I click on not again, I drag it inside and I select the gender again, inter edge, and I select female this time. So I should show the nodes here. So that's the picture before I apply the filters. Let me repeat what the filters do. So again, you have to start, when you explain filters, you have to start through the inner section. So hide the edges that connect nodes that have the same gender, which is female, and hide the edges, so the not is for hiding, and hide the edges that connect two nodes that are males together. And if in the remaining nodes, once you have removed all of that, if a node has 0 connection left, you should delete this, you should hide these nodes. So let's apply this filter, and we should see now that, or let me increase a bit the size of the nodes, otherwise I will not be able to select them, or it's going to be harder. That's big. Well, never mind. You see that if everything went well, yeah, you see that when I select a node, it shows only the connections with the opposite gender. Oh, not here, so something went wrong. Why is that female, male, not, degree is fine, no, degree should be at 1. Oh no, I understand. It's because my selection area is too big. I'm selecting 2 nodes. Yeah. No, this one is selected, is connected to the same gender, so it doesn't. Why is it connected? Why a female character? While the connection between 2 female characters has not been removed. Okay, I'm going to spend a bit of time on this one. Or maybe that's not nodes. Maybe it's not edges, it's not nodes. Oh, no. Yeah. Okay. Still we have 2 male characters being connected, even if I asked there for a female character not to appear. This one is fine, this one is fine, this one is fine, this one is not fine. You see, that shouldn't be the case here, so what's wrong? So what it says is remove the edges that connect 2 identical, that connect nodes that have identical genders. You know, that's what this thing here is saying. Gender. Keep only edges between elements from the same partition. and I negate that with a not. So it should be, that should be remove these things instead of keeping them. Filters are tricky. Keep only edges between elements. And I said not, so not should, but is it mask? No. And what about intra edges? What is that? Keep only edges between elements from different parts. That's better. That's exactly what I want. Okay, maybe I should just do that then. I'm gonna remove that. And I'm gonna drag this one here. That's let's see. Yay! I think I got it. So it's not what I had prepared, but I think I got it. Let me show you here. So now what I have done is what I wanted to do, removing the edges between the characters that have the same gender. And it was a simple intra edges filter, this one. Because it says, let's read it together, keep only the edges between elements from different partitions. So if you have the gender attribute that has two partitions, male and female, this filter keeps the edges between characters that have different values for the gender attribute. It will hide the edges between characters that share the same value for gender. So males connected to males and females connected to females. So, okay, back on track. One way to visualize the result is just to apply the filter. The edges will be removed between males connected to males and females connected to females. But another possibility is to use this pretty neat feature, which is at the top of the filters panel, and it says, no, that's this one with an A, hide the labels hide the labels from the nodes and the edges that were filtered out. So let's do that. Yeah, we don't see a big difference, but you see that, oh yes, actually you see that I stopped the filter, so the filter has all the nodes and all the connections from the original network, but now because I have applied this thing here, the labels from the males connected from the males that are not connected to females have been hidden from view. So basically the nodes that you see here with labels, and maybe we can just scale the nodes back to 1 now. It's gonna be the names that you see here are from characters that connect with characters of the opposite gender. what is hidden from view is the labels from the characters that only connect with the same gender as themselves. So like this one here connects, is a male, and he connects only to males, and their labels have, his labels has been removed. So it's a good way to basically make visually, to translate visually the result of a complex filter. If you ever, and that's something I struggled with, if you ever want to get back your all your labels into view, because you are finished with this part of your analysis and you want to move on and you need all your labels to be back on to view, then this, what is it? This icon does what you need. Reset label visibility. And if you do that, all the labels come back into view. Okay, so we are a bit over time actually, but as you see, it was a struggle to get these filters right. But we did it in the end, and sorry for the disconnection in the middle of the stream. I'm gonna cut them and trim them for the replay, but thanks to the two very courageous viewers who stayed till the end. So that's it. I think we covered a lot. Everything that I wanted in any case, and for the next Wednesday we're going to cover something pretty different, which is how to publish your network, the one that you have in Gephi, directly to the web. That has been made possible in a very easy way recently with a new plugin that has just been published. So we're gonna practice it next week. Thank you all. See you next time.